Let's look at some advanced scenario design patterns. We're going to look into how to prevent duplicates being passed over to certain systems. We're going to look into how we can pass details from one route to another route and pass variables, just like this Converger module that everyone is talking about. Let's get into our first example or first design pattern, and that is preventing duplicates. I've prepared a small scenario over here that is simply taking our country areas list from the previous training data, and then it's iterating it and it's passing it over to a Google Sheet and either updating or adding a row depending on if it already exists in the Google Sheet or not. So our Google Sheet looks like this. We have country, area, and square kilometers created and updated. Here I'm planning to add the timestamps so I know exactly, okay, when was this row added and when was it updated. Now the individual setup, I already showed this module. We are getting the data from our training data. We parse the response. This needs to be turned on. Then in the advanced settings, we turn on the evaluate all states as arrows. Now we iterate the data so we get each country individually. And then the Google Sheet search rows, we use the spreadsheet that we've created with the sheet name ARE list. And then we filter by country name equal to the country that we get from our data. Remember, this needs to be a unique identifier. So it needs to be something that is really unique to that specific entry, like an email address, a user ID, or in our case, it's the country name, which is very unique. And usually I want to set the maximum number of return rows to 1 because there should only be one result and I only want to update one result. Then there are two filters, or a router and two filters. First, country exists if the row number was found. So the basic operator exists. That means the country was actually there inside the list. And then I want to simply update that specific row. So I use the same spreadsheet. I can also map that from my previous module here like this. And then also map the sheet name if you want to have it more dynamic. And you also use the row number here from the search rows module. So make knows which entry to update or which row to update. Then we add in the area and square kilometers value here, and we also overwrite the field updated with our current timestamp. So we get the correct timestamp inside our Google Sheet. The second path is country does not exist. So if the row number does not exist from our search rows module, we know, okay, this is actually a new entry. We have to add a new row. Same setup as the updated row, except there is no row number here because we're simply adding a new row. So spreadsheet, the sheet name, then we add in the country name, the area and square kilometers, and here we update the created timestamp and add in a now timestamp so we can refer back to this later. Let me run this once to show you how that looks like. Since there haven't been any entries in our Google Sheet before, it searched it 10 times and 10 times it found nothing as the output. So the total number of bundles is 0. And then the filter at the bottom, row number does not exist, matches 10 times here. So it matches for all of them. And that's why it added 10 new rows to our database here. So actually the created timestamp, this was formatted in a weird format. So you simply have to go to format and then number and change this to date and time format, like this, for example. And I will do the same for this one. So it actually formats it correctly right from the beginning. Now let's try to run this one more time and see what it does this time. Right now, it actually found all entries because we are searching based on the country name and it always found an output, which means the row number exists. And that's why it passed through the filter at the top. We have a row number always, and then it simply updated these ones and added the updated timestamp here. So here we got the updated time, and now let me kind of prepare or remove a couple of things. So I will delete this row, I will delete this row, and maybe the last one, and maybe Russia as well. So we're deleting these rows, and these ones don't have an updated timestamp. And now let's see what the scenario is doing. Okay, so you can see now it added 4 new rows because we have deleted 4 rows before, and it updated 6 other rows. Because here are the results. Some haven't found anything. So for example, this one was filtering for Russia. It was not found in our list and was outputting 0. That's why it added a new row. And this one, Canada, was actually found, and that's why it went the upper path and updated the row. So to look at it on the Google Sheet, it added the updated timestamps and it added the created timestamps for the newly added rows. And now you get an updated database and you don't get any kind of duplicates. Common use case for this concept or pattern are databases, like in that case, or email contacts by searching an email first in your system, then updating the contact, or adding a new one if he doesn't exist before, or other things. Now let's get into a second advanced scenario pattern. We have the area of countries list one more time. So checking the output of this one, we get the 10 countries in our area list. The setup is the same as before. We get the URL, we have the parse response ticked, and then show advanced settings and evaluate all states as arrows. And then we're getting the data out. Now, our goal is to get the min, max, and average value of the area in square kilometers. So our array is over here, area in square kilometers. What we need to do for this one first is using an iterator to iterate our data, and then we can use aggregator. So we use the numeric aggregator to calculate the average, min, and max values of our area in square kilometers, using the iterator as the source. And now we are going to use the average first, and our value is the area in square kilometers. And now save this, ignore warnings, and run this once to see what the output is. And we get an average square kilometers of 7,358,703.9. So let's rename that to average. And then we also want to calculate the min. So if I add that in here, it will simply add a router. We can use that. And you can also use the router with aggregators, and we'll go through all paths. So right now we want to get the max out. Let's rename it right away. Max. Save, run once. And the max over here is 17,089,246 kilometers square. And getting out the min, let me just clone it this time, connecting it to the router and using the min here. And I will also rename that one. Make it beautiful, save, run once. And now the min value is 2,381,741. Now we want to get all this data out and want to send that in one single email. But how can we get these paths back together? There's no straight Converger thing module that you can do to just connect it back together. And that's why we have to use a little workaround by setting a variable first. So set variable after this one, the numeric aggregator, we can just call it average. And then using the result of our previous module like this. And then we can rename it set average, average clone. And this is our max. We need to update the variable to use the new aggregator. And that is called set max. And then one more time. Here we could also skip that one, actually. So either like this, min, 1 second. So you can either do it like this and then use another router here to get multiple variables and then simply get the variables average, max, and min. And then send yourself an email or forward it somewhere else where you need it. Average is this one. We are to add a new line, max, min. All right. You have to make sure though that this is the path that is coming after the setting of the variables, of course, otherwise it won't work. So let me organize that one and then running this once and see the whole output. Too many requests. We are at about 50 seconds right now. So let's try it again in a couple of seconds. Here we go. So it processed everything. It set the average variable here. It set the max variable here, and it set the min variable here. And then we got all these three variables out, the average, the max, and the min, and we passed them forward inside an email with the content average, max, and min. You can also pass or append this here at the last path of your previous path over here. So you have the router and then it processes the average first, then the max, and then the min. So you could also remove this one and just simply skip this one and then append it here. And we are not setting the min, so that will be excluded. And then we send the email over here with the results straight from our text aggregator. And then disable that route, run this one more time, and it would work exactly the same. So on your last path, you can get the variables of your previous path and then continue with your scenario just like you would normally do. That is oftentimes helpful if you would otherwise copy the same modules that are coming afterwards to the other path, and that way you can save a lot of maintenance work if you need to update something. For example, if I would have to make a change to the email module, instead of sending everything individually, I can simply make the change here and it would work. Or if you want to combine the text, like in our case, and just send one email instead of 3 different emails with the average, max, and min values, then we can also do it this way. Now there's also, just to mention here, there's also an easier way to calculate the min, max, and average value where you don't need the aggregators for. And I will show you that right now. So setting multiple variables for testing purposes, I will disable that route for now. And then we are using the average and using the map function like shown before with the data as the array input. And then the area and square kilometers is the key that we only want to get out in a simplified array. And then there are math functions over here for max and min and average. And we can use this to calculate the average of our area and square kilometers. So just like this. And we can run this to see if it already outputs the average. It had error again because we're about 50 seconds. So let's wait another couple of seconds. I will also enable this route so we can compare the average values against each other. Okay, so the average over here shows 7 million. And over here, it has the same value, 7,358,000. Let's do the same for the max value. So we can basically use the same mapping formula and then simply replace average with max. You can also find that under the X tab and then max. And run this one more time to compare the max values with each other. Our max from the numeric aggregator is 17 million. And here it is also 17 million. And lastly, we want to do the min. Same concept as before. You can also type the function if you know it and then open the parentheses and it will transform into this gray function. And run this one more time, comparing the min against each other. The min numeric aggregator value is 2,381,000. And over here, we also have 2,381,000. Okay, so that's an easier way to calculate it, and it also saves a lot of operations. But of course, this one is also working very fine. And here you could now just add the email, send an email, and map those values directly here. The average, the max, and the min. To wrap it all up in summarizing the advanced scenario design patterns that we have looked at today, we checked out how we can prevent duplicates in our target system, for example, in a database or in our contact CRM system. We have looked at how we can pass variables from one path to another path, or using advanced average, max, and min functions directly with an array to summarize them and send them over in one single email. That's very helpful and it's a workaround for the Converger module that a lot of people are looking for. Let's move on to the next lesson.